We talked about humans and how their population is rapidly growing. Although the population is slowing down, we saw that with the world TFR, some countries are still rapidly growing. And as a whole, we're growing, which means we need resources. All sorts of resources. So this diagram is talking about social needs, Wi-Fi, although Wi-Fi itself isn't a resource, but all the electronics hooked to Wi-Fi that give us Wi-Fi. We also need more important things like food and shelter and water. And with a growing population, we need more resources. Now, resources are used in everything and in things that we don't really think about. So here I have an example, a 1/4 pound hamburger. If I look at just the burger, the patty itself, I'm not looking at any of the toppings, I'm not looking at the buns, and I'm also not even thinking about shipping, packaging, or processing. Not thinking about any of that, just at that patty. You're like, oh, okay, that takes a 1/4 pound of hamburger meat. That's the resource I'm using. It is, but that came from a cow. That cow had to eat things. So for just that patty, 14.6 gallons of water went into it. That water was used for the fields to grow the hay or grass that the cows were eating, as well as the water the cow drank. You also needed 13.5 pounds of feed, so food for that cow. Now, that's not for the entire cow for its entire lifetime, because remember, this is just one patty, and you get many patties from that cow. So 13.5 pounds of feed just for 1/4 pound of meat over its entire lifetime. But a lot more food was given to that cow for all the other hamburgers created. You need about 65 square feet of land. Although that doesn't sound like much, again, this is one hamburger patty of the thousands, maybe millions of patties in the world. And it creates about 1/10 of a pound of methane. Methane is released from cows when they fart and when they burp. And we'll explore this more when we talk about climate change, because methane is a pretty strong global greenhouse gas. Now, these resources we can divide into 3 separate groups: inexhaustible, exhaustible, and renewable. You've probably heard about renewable and non-renewable resources, but scientists have kind of moved away from those terms to better describe what these resources are. So we'll first talk about inexhaustible resources. They are not exhaustible. We can't run out of them. You'll probably learn these as renewable resources before. So examples include the wind, the oceans, the waves, the sun. These are usually things associated with renewable energy. You think about using windmills to capture wind energy or solar panels to collect solar energy. These are things we can't run out of. As long as the earth is spinning, we're going to have wind. As long as we have a moon, we're going to have waves. As long as the sun doesn't burn and explode, we're going to have the sun. Even if we can harness the energy from these resources, we don't use the wind, we don't use the sun. It's still going to keep coming. On the other side of the spectrum, we have exhaustible resources. These are things that we can use, and they do get replaced, but really, really slowly. I'm talking hundreds of thousands or millions of years. So once we use it, more or less, it's gone. Like, I might use all of one thing today. I'm not going to see it until after I'm dead. Maybe humans aren't even around at that point. Like, they're not going to be able to be used. One example are fossil fuels. This picture is showing coal, but there's also oil, which gets used for gasoline, and natural gas, which some of y'all might use in your homes for cooking. This kind of resource, once we use it, coal and oil and natural gas are made naturally by Earth, but it takes millions of years. So in our lifetime, like once it's gone, it's more or less gone. Another example are minerals. So here I have a picture of copper and aluminum. Although there are tons of them in Earth's crust, again, take a very long time to form again. And actually, in the examples of these, they don't form again. Once we've used them, that's it. We need to recycle them somehow in order to reuse that mineral. Fortunately, there's so much of it in Earth that we probably won't run out of it just because we have a lot as it is. Another example is sand. Now there's tons of sand on Earth. We probably will not use all of it. We use it to make glass. But the point just being that once it's used, it's created by the weathering of rocks. Weathering of rocks takes thousands and thousands of years. So if we were to use all the sand on Earth, it's not coming back. Not during our lifetime, not during our grandchildren's lifetime. So again, once these are used, that's it. And you may have learned these as non-renewable resources. Now, a term that you probably are familiar with are renewable resources, but again, this isn't solar energy or wind energy. This is something a little bit different. These are resources we can use, but they come back, and they come back in a useful amount of time. They might come back in a couple hours, days, weeks, years, maybe centuries, but they come back and we can reuse them over and over again. So one example are trees. We use trees for firewood, we use trees for paper, for furniture. And when we cut down a tree, yes, that uses that tree, but trees grow back. Depending on the species, it might grow back in 10 years, it might grow back in 100 years. But then we can chop it down again, make more paper, and just repeat this cycle over and over again. So again, it's not inexhaustible, because we could chop down all the trees and then they don't come back, but it's also not exhaustible either, because they do come back. So it's kind of somewhere in between. Another example is fish or deer or some other food source. We might go catch fish and eat it, but fish reproduce, which means there'll be more individuals in a couple years. Another example is water. Now, although we take out water, we as humans drink it, and then we pee it out. It goes through a wastewater treatment plant and it actually goes right back into the river. And it goes through the water cycle, and we just repeat this process over and over again. So there are ways where we can take too many, but because they come back, that's why we don't consider them an exhaustible resource. Now, related to these renewable resources, we as humans have to be careful of how much of this resource we take. We want to stay somewhere in the sustainable yield. What this means is the highest rate or highest amount of a resource we can take forever without reducing how much is available. So for example, imagine I have a pond with 100 fish, and I go out and I take 20 fish. And I wait a year before I go to that pond again. And over that year, those fish reproduce, and I go back to the pond, there's 100 fish again. So I take 20. And the next year, there's 100 fish, and I take 20. And I could keep this up forever. The fish are replenishing and replacing the ones that I took out. I am at the sustainable yield. I could probably take maybe 30 and still have the same thing happen. That's a sustainable ecosystem. Now let's do another pond. This pond also has 100 fish, but I go out, I take out 90. So only 10 fish are left. And I go back next year and I look in the pond and there's only 30 there. Yeah, they reproduce, there's more of them, but I can't take 90 again. There's not 90 fish there. So although it's a renewable resource, more fish came back. I over-harvested. I took way too many that the population wasn't able to sustain itself. I would have to choose not to fish there again, or maybe I take out all the fish because I don't care. But the point being, it's something we have to be cognizant of with our renewable resources. So let me show you a real life example of fish. One type of fish that is out in northeast United States, around Canada and around Maine, is cod. We use cod in like fish sticks and like fish fillets from Wendy's and Burger King and fast food places. Cod went more or less extinct in this area. For a very long time, for about 100 years, from 1850 to 1950, we're making good catches. That's what this graph is showing us, is how much fish were we harvesting. So we were harvesting, 100,000 to 200,000, 300,000 tons of cod every year. Really, really good. In 1960s, we had a boom. We had better technology for finding fish. We had bigger boats, we had bigger nets, and we had more people. So we were able to fish a lot more and catch a lot more of this fish. But we caught too many. We surpassed this sustainable yield. We are hitting 800,000 tons of fish, which meant there weren't that many left in the ecosystem. Yeah, there were still some left, and they reproduced, but the following years, we couldn't catch 800,000 tons again because there weren't 800,000 tons. And so we just didn't. We didn't catch nearly as much, and the population crashed. But, we stopped for a little bit, and they recovered a little bit. And we saw, oh, the numbers, they're getting bigger. We can catch more of them. And we did, and we more or less caught them all. We couldn't find any more, and the population crashed. Now, some of you maybe have noticed fish fillets are coming back. And a couple years ago, there were commercials by Wendy's, by McDonald's saying, we're bringing back the fish fillet. The reason it was gone in the first place wasn't because people weren't buying them. It was because we didn't have them. We didn't have the fish to supply that food. So an example of how humans overstepped the sustainable yield, and it affected our economy, which is what most people care about. How does it affect our money? But it also affects those ecosystems. Animals eat cod. Cod eat other animals, so those ecosystems were greatly affected as well. Another example is menhaden. Menhaden are used in fish oil pills, and fish oil is so heavily marketed. It cures like everything. Have bad hair? Use fish oil. Need more nutrients? Use fish oil. Having a bad day? Take fish oil. Like everyone says, take fish oil. So more people catching menhaden to make more fish oil. Now this is looking at surveys of how much menhaden were in our ecosystem, and this is in billions. In 1980s, around 200 billion menhaden were estimated to be in our ecosystems. 30 years later, we're looking at 20 billion. So almost a 90% decline. Now you may think, well, 20 billion is still a lot of fish. It is. Don't get me wrong. But it's a lot less than there used to be. We are taking way too many fish that they can't replenish their population. And we keep taking and we keep taking. This is essentially human greed that you're seeing. Again, not only hurting our economy, but also hurting the ecosystem where these menhaden are found. So thinking a little closer to home to Maryland, if any of y'all fish or have friends who have fished, you've probably heard about people getting a fishing license and maybe fishing limits. There's a lot of limits put on what kind of fish you can catch, when you can catch it, how big they can be, and how many you can keep. So let me talk about a couple of these, and we'll use the largemouth and smallmouth bass as an example. There's a size limit for these fish. If the fish is 12 inches or bigger, you can keep it. That's your fish. If they're smaller though, you have to put them back in the water. You're like, well, I don't want to, I want to keep it. Well, the reason why there's this size limit is larger fish are usually older fish, and older fish don't reproduce as much. Sure, they make eggs, they make sperm, but they don't make a lot. But those smaller and younger fish, they actually make tons and tons of sperm and eggs, and we want to keep those in the ecosystem. They're going to be the baby makers. They're the ones that increase that population. However, the bigger ones don't really contribute much, so you can keep them. The largemouth and smallmouth bass also have a fishing season. You cannot fish for them between March and June. This is because that is their peak reproductive season. You don't want to keep any of them, the big ones or the small ones. They're all reproducing now, so by preventing fishing during this time, there's more chance that reproduction will happen. And then finally, the creel limit. The creel limit is just how many you're allowed to keep. For example, for the bass, you can keep 5 each day, or 10 overall. So if you have, say, 10 days on a fishing trip, you can only keep 10 on you. Even though you can catch 5 a day, you can only have 10 total. Now some people criticize this and say, well, I want to keep this, or I want to fish more. Like, this is my water, this is my land. And it's not meant to be a regulation. It's not meant to hurt us. In fact, it's there to help us. It's maintaining this fishery for many, many, many years to come. It's maintaining the sport for us. It's also maintaining the ecosystem. You know, the bass eats things, things eat it. It's an important part of the ecosystem. This is the same for hunting licenses and of different animals as well. So next time you hear someone complaining about it, tell them, hey, if we didn't have these limits, people would fish as much as they want, and maybe in 10 years, there would be nothing left to fish.